All right, so let's take a look at our situation. So we have a pool with dimensions 20 by 10. So let's say this is 20, this is 10. And around that we have a walkway, which is X meters around on all sides. So X, 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 X. So now we have the total width of this as 20 plus 2x and 10 plus 2x. So that's the area of the whole region now. Okay. So now we want to find an expression for the total area of the pool plus the walkway in factored form. So we want to just multiply our 20 plus 2x times our 10 plus 2x. So this is in factored form. If we expanded this, we'd end up with 4x squared, which is the 2x times the 2x, plus the 2x times 10 would be 20x, plus the 2x here times 20 would be plus 40x, plus the 20 times 10 would be plus 200. And when simplified, this would give us 4x squared plus, we can combine these two, 60x plus 200. Okay, so the walkway around the pool can be divided into 4 squares and 4 rectangles. So let's take a look at how we could do that. Well, so each of these areas here are going to be squares. Sorry, this is so messy. So each of these is going to be x squared. So we have 4 of those. We have 1, 2, 3, 4 of those. We have 1, 2 of these areas, each of which are 10 by x or 10x. And we have 2 of these areas, each of which are 20 by x or 20x. So if we want to look at it as a whole, we can say the walkway has the 4 squares, which are in area equal to 4x squared, plus we have 2 rectangles, each of which are 20x in area, plus 2 rectangles, each of which are 10x in area. And we could say, if we simplified that, that would give us 4x squared plus 40x plus 20x, so plus 60x altogether. Okay, so let's now take a look at the expression for just the walkway. So let's take a look back at our walkway. So we said that the walkway is 4x squared plus 60x. So we have 4x squared plus 60x. So if each of the tiles we're purchasing for the walkway measure 500 centimeters by 500 centimeters, which is to say half a meter by half a meter, then how can we figure out how many tiles we'll need? Well, we know that the number of square meters of tiles we need is 4x squared plus 60x. But each square meter, so a meter by a meter, can be divided into 4 tiles, each of which is 500 centimeters by 500 centimeters. In other words, half a tile. So we get 1, 2, 3, 4. So if we take the number of square meters and multiply it by 4, that'll give us how many tiles we need. So we get this, and then when we expand, we get 16x squared plus 240x. All right, so if the tiles cost $P a piece, what expression shows the total we'll have to pay for the tiles? Well, now we have to multiply our cost per tile, P, times our number of tiles, which we said was 16x squared plus 240x. Okay, so now what this is telling us is that the minimum walkway is 1 meter. The width cannot exceed 3 meters. So we want to set up an inequality to show the minimum and maximum amounts that we'll have to spend for the walkway. Well, we know that our walkway cost is given by this expression right here. And x is the number of tiles, and, or I should say it's the width of the walkway in meters. So if we replace x with 1, we're going to get p times 16 times 1 squared plus 240 times 1, which is going to equal 256p. So that would be our lowest cost. But if we set our value at the highest possible width, we're going to get p times 16 times 3 squared plus 240 times 3. And that's going to give us here 9 times 16, which is 144, plus 3 times 240, which is 720. So 144 plus 720 is 864. So that's going to be our highest possible cost. So our inequality would be that the cost would be less than or equal to 864p, greater than or equal to 256p.